All right, so let's go back to the trig graphs, right? So what you will recognize in trig graphs is that I take a quick look over at the trig graphs, plus sign and tan.
Right. So how you look just see.
Right, so we know these graphs, right? We know the graph for sine, right? We know the graph for, I just drawing one cycle alone, right? We know the graph for cos. Right, and we know the way the graph for tan looks, right? Huh? All right, so we have an idea, we have a general idea of what the graphs shape like. But like a question came this year, they didn't ask about the graph, right? About the code, right? Right, we need to be able to draw any graph here, but making a comment for yours first, huh? Right? So we need to draw any graph. Right? I think I gave you all the general form. The general form for a graph is y is equal to a sine bx plus c. Right? It could be sine, cos, or tan, it doesn't matter. But this is the general form. Right? A gives you the amplitude. Right? B helps you find the period. Period is equal to 2 pi on B, and C gives you the vertical shift. Right? So all these things could be applied to those graphs. All right, so I'm going to start with an example here. Two pi on B in radians, right? I didn't talk to you about radians, and you all know about radians now. Right, in radians. I didn't do radians as yet without it once. It's in radians, we need, huh? That means that right, just to give you a clear picture, sticking with degrees, right? I'm sticking with degrees. Because I didn't really show you radians as yet. Right. How do I get? Right, so if you look here, first thing we have to figure out is what is A, what is B, and what is C. A is how much? A is 5. B is what? B is positive 2, and C is minus 3. So what is that? What does each one of the letters do to the graph? Right, so we now started, right? So let's take a look here first.
What's one thing?
Right? Where would why take so long?
So how do you say okay? Somebody stuck with the
All right, so how do we draw this, right? So based on these values, right? Based on these values, we have to be able to sketch the graph. The graph is still going to follow that shape, right? But a few things going to happen now, right? This A value tells us that our amplitude is equal to 5. Remember I told you what the amplitude is? The amplitude is from equilibrium line to the highest point. That is your amplitude. Right? Period. Your period is 360 divided by B. So your period is 360 divided by 2. Sorry. Yeah, 2. So that's 180. So now a period gonna take 180. I want you to draw something here between 0 and 360. So I want to draw this between 0 and 360, right? So we're gonna talk about each one of these just now. And what can we say about the shift? -3 means what? Means it's going to shift downwards. It's going to shift downwards 3. Okay? So that's what each one of these letters say. How we gonna show it on a graph now? Are you okay with how I went from here to here? To each one? To each one? So how do I get period? Period really. All it means, if the period is 180 and I have to go up to 360, then I should get how many cycles? 2. Right? Period is 180 and I have to go up to 360, so I should get 2 cycles. Right. What does this mean now? This means that my entire graph shifts down 3. 1, 2, 3. But this whole graph, picture it 3 down. This amplitude of 5 means that the graph, how high does a sine graph normally go? It normally goes to 1, right? Now it has to go up to 5. All right, so let me see if that make any sense. All right, so watch here. I'm gonna do all the shifts. I'm gonna start with the first graph. I want you to watch all the shifts, right? I did not go so far, I tell us. All right. So normally sine graph looks like this. It goes up to 1, comes back down to -1. Normally the sine graph looks like this, sorry. And that's true. That's normally the sine graph. Yeah. What the question said. Amplitude of 5, right? So how high do I have to go? I have to go up to 5 really, right? So I'm taking up this and I'm going up to 5. Right? So that's the first shift. Allocate the first shift. And look at another way here. Normally you do it on graph people. Right? Allocate the first shift. Second shift now. Period is 180. So one of that's supposed to take how much? 180, right? That's okay? Chris? No? You got lost already? Right, but you're okay with here, right? Right. The formula for period is 360 divided by whatever B is. Right? That is a relationship. So B is how much? 2. So 360 divided by 2 tells me now that the period is 180. So one of these cycles taking 180 now. Right? But I don't want to. I just feeling kind of lazy, right? I'm going to change this here to 90, this to 180. That's okay? But how far I have to draw until 360, 90, 180, 270, 360. So I go again. Okay with that? That's the first 2 shifts. Right online? That's the first 2 shifts there. One more shift. Now I have to take that whole graph and bring that graph down 3. Right? How are you doing that, step 1? Right. So I jump in the graph 3, right? So what would change? Amplitude change. Amplitude is from the equilibrium line to the maximum point. So if I drop this down 3, where will it start? It will start at 2. Where will it finish? It was at -5. Where will it be now? -8. That's okay. What else will shift? The equilibrium line, right? This was the original equilibrium line, but now we shift everything down 3. So this is our new equilibrium line. That's okay. So your graph. The graph will look like the black line. Right? But the reason I show you the black line is that you don't have to draw the blue line. Right? You need 3 important points. The 3 important points you need are the equilibrium line, the maximum value, and the minimum value. Once you have those 3, you can sketch it. And of course, period. So how we could get the max, the min, and the equilibrium line? I give only a hard one. This is a very hard one. I give a hard one time, right? The one that came this year was, I'll give it to you. After. Right. How do we find the maximum value? How do we find the minimum value? And how do we find the equilibrium line? So that we don't have to waste time doing all 3 graphs. We can just do one time. Or we can get, let's start with the equilibrium line. The equilibrium line is obviously what? What's it good? 0 plus the shift. So the equilibrium line is just the shift. Right? Because you'll keep getting the shift, right? Very good. Right? So the equilibrium line is the shift, which is -3. Right? To be exact, let's put y is -3. Right? How to get the max value? Say it again, please. Minus a. Right. So what she's saying is the amplitude plus the shift. Right? The amplitude was 5. 5 plus -3 is 2. Minimum. What would that be? Minus a plus the shift plus the shift. Minus a plus the shift. So that'll be -5 plus -3, which is -8. That's okay. So I just did the tree graphs to show you how everything shifted, how everything changed. But these are the important things that you need to do. All right, copy down only the black. Copy down only the black, and let's get rid of the charge. Let's try 2. Try 2 on the one that came for example. No, George, no. George, straighten your notebook.
There's a job of the city. There is a. That's still. Yes. We can do it first. I can go first. That's it. Yeah, that's one thing.
Right, sorry. Right, so for the first few things that we need to get ready, we need to get A, B, and C. Right, we need to get A, B, and C, and then get the maximum and equilibrium line, right? I'm gonna give you one of you chance to it. So it in the book. And I'm gonna stretch out the time. We just learn plus and sine. Right? I'll give you a tangle over. Try that it. Try this one. 3 sin x plus 1. Right? And I want you to get the same thing, right? Everybody doing this else? Taking this off, right? I take your time. Try and figure out the A, B, and C, figure out the shift. That's like, yeah, B. Time I try to need this. One line, when it finished, you can take a pick and send it, am I right? Right, we look at it, do the rule from after you pick it, topics, your rule. What's up, what it is again? Yeah. I see now like. Oh yeah, so yeah, volume. On the next ready? Yeah. Yeah. Josh, what are you doing? Huh? When you finish, you go to that. I don't know what's that. Right, so write down the ABC, amplitude, the period, the shift, max, min, and equilibrium, and do your sketch. Huh? Yeah. Yeah, answer that, yeah. Try that one, it is, so you get. Try that one, it is. Try that one. Um. Try that one. All right. So what is here? Right? A is how much? B is, C is 1. Amplitude is 3. The period is 360 on 1, which is, so the period not changing. And the shift is positive 1, so that's 1 upward. Right? How is that helpful? Well, it tells us that our maximum value is 3 plus 1, 4. Our minimum value is minus 3 plus 1, which is minus 2. And our shift is y is equal to positive 1. That's all. Okay? Now we could use these 3 things. Right? Now we could use these 3 things and sketch it. Right? So the graph, we know the new equilibrium line, y is 1. It's going up to 4 and coming back down to minus 2. Right? So it's going up to 4, coming back down to minus 2. Right? The mistake that we tend to make sometimes is that we stop at this line, right? You're not stopping at this line. You're stopping and starting at the equilibrium line. That's okay? Now, when you reach here, all you have to do, deal with the angles after, right? The period is 360. So this here is 360. Right? Here is around 1/8. Okay with that? Don't put these labels, don't put these labels on this line, right? Yeah. Huh? Why I went? Why I went above this line? Because of where the max value is. That's what the sine graph is, right? So remember, it has to look like this, huh? It has to look like this. Right? It's a version of this. So you have to go up to your max. Because the shift is one upwards. The last one, it was three downwards. So the whole graph went up one. Take it in and see. Oh. Right, but you follow how I get this, right? Right, so forget what I have here. How long does this take? So this cross 360. So it will stop here when the angle is 360. That'll. Does it? And if here is 360, halfway is 180. Yeah. All right. Okay with that? Yes. Online, any questions on the graph? Online, any questions on the graph? Kiara, you okay with it? Let's take one more. Right, you're gonna do one with customer now. Focus 2x minus 3. Right, between 0 and 360, right? Try that there. This one here. Focus 2x minus 3. And Sean join me, please. Some wallet shift with you. Can you grab the very card? Very good. So it's a cost graph, right? So regardless of the shift, it should look like this in the end. One cycle should look like that. Here, one cycle should look like that. Oh, I should keep all the
You want to see what is about.
All you remember, I have to zero the right? I have to zero the period. How many cycles am I supposed to get? Right, so you're supposed to have A is 4, you're supposed to have B is 2, and you're supposed to have C is -3. So the amplitude is 4, the period is 180, and the shift is 3 downwards, right? So here, I need to be able to get the max value. The max value is 4 plus the shift, which is 1. The minimum value is -4 plus -3, which is -7. And your equilibrium line is -3. Right? Once you get this, all your work done. Right? Leave it period out for last, right? Leave it period out for last. So your equilibrium line is -3. Period is how much again? Period is 180, right? So you're supposed to have 2 graphs, right? 2 cycles, right? Supposed to have 2 cycles. Fix it quickly. Yeah. That's probably good. Right? So we're starting at what? It's cross graph, so it starts at the maximum value. So it's starting at 1 and then coming down to -7, right? And it will come back up. That's 1 cycle. Two cycles. Yeah, it's 360. Yeah, it's 180. So your graph will look like that. Right? Starts at 1, comes down to -7, comes back up to 1. That's 1 cycle. Up again, next cycle. And that's it. Okay? I want to shift to something else, but I don't want to give you too much hard ones on this, right? But your homework, I'm giving you 2 for homework. Your homework is the one from 2025, which is sine or cos 2x, right? I'll look back for it, but in 2025, they gave you a easy one. Cos 2x. I think it's both of them, right? Try these two places for homework, right? Sine 2x and cos 2x for homework. All right. So I don't want to spend too much time on this. This will always come. It came for the first time this year. But I want to make sure that I can at least understand when you see these values, how to sketch it, right? And you recognize those much easier, right? Where you recognize change in here alone. What change in here alone? Period. Right? Amplitude staying the same and the shift staying the same. Huh? Huh? All right. Sine 2x, cos 2x. One of those schemes. I can't remember which one it is. How does it bring it? There's different values and after we do a summary. After we do, yeah, take a summary to a box and stuff from it. That's the summary. What summary? 47. Yeah, of course. Yeah, go on to the summary because you need that first. How you get it quarters? I do a short summary, but you want to start with a look at it. Right? Like go through everything without problems. Like something. All right. The next thing that we're gonna do for a little while, we're gonna take a look at trig identities. Right? So we're gonna take a look at trig identities, right? So one of the identities I gave you already is tan theta. Tan theta is sine theta over cos theta. Okay? And next one that I need to learn is sine squared theta plus cos squared theta is 1. If I were to move across cos squared here, I will get sine squared is 1 minus cos squared. And if I were to move across sine squared, I'll get cos squared is equal to 1 minus sine. So for now, these are all the rules that we have to learn make on. Copy them down. Right? So for now, these are all the rules that we have to learn. All right, so look here. Here's what we got to do, right? What we need to learn to do is to use our rules, use our identities, 1, 2, 3, 4. Use those identities to show that the left-hand side is equal to the right-hand side, or at times the right-hand side equal to the left-hand side. you have to be able to show that. So you have to be able to show that this somehow simplifies to give me this. All right, listen, Vishesh, watch here, please. Watch here, all here. That one, all right. I'll watch here. So how am I going to show that in the left-hand side? How am I going to show that this is the same as this? Right? The only way I could do that is I'm going to have to find a way to use identities there. All right? So watch this here. Huh?
That's what this is.
Who's that? Right, so watch this here. So I need to find a way to show that. I need to find a way to show that sine theta divided by tan theta, that is equal to cos theta. Okay? So how do I make this turn into cos theta? I have to use one identity there. Right? Oh yeah. There is no identity here for sine theta. None. Right? Don't write sine theta as 1 minus cos theta. That's wrong. This only holds for sine squared. Okay? Right? So there's none for sines. The only one that we have here is tan. So we could say that tan is equal to sine theta over cos theta. Now, what I could do is I can flip this over by changing this to a multiply sign. And then you will see a sign cancel. And you'll be left with cos. Right? Once you do that, you could write QED or draw a little box, which means I prove it. You prove that the left-hand side equal to the right-hand side. Right? The trick is choosing the right identity. Yeah. Can we not no, you can't work with both sides. Right? You can't work with both sides. Can we not multiply by 1 on sine theta on both sides? Right? This symbol here, this symbol is not like an equal sign where you can do that. Right? That 3 equal signs means that you can't perform functions like that. Either work with the left or the right. Huh? You don't put 3. You don't put it after. Try this, please. I make a mistake and give already. I give already a hard one now. Hold on, eh? I was supposed to leave these files on the board there. One. Try this, huh? Take your time, it's a little tricky. Sorry, to get there medium. This is the second medium. No, not medium. Right? You can do any side you want. Huh? If you like the right hand side, no, go right ahead. Right? My advice to you though. Go to the left hand side. Right? Take your time, find the LCM. Take your time, find the LCM. We'll see what you got. How the denominator be separate? That's all. I gave it a minute. I'm gonna get it up. Get it up. Oh. Yeah. Find the LCM. Find the LCM and see how it's 55. Right, so if you see why is make this hard, right, Claudia? Is that well, why is make these identities thing hard? Is that you have to be able to use your algebraic rules properly, right? So if that was an X, I would have done this, right? I would have said that my denominator cos, right? This by this is this. 1 by 1 is 1. Cos by cos is cos squared, and then I put this sign in the middle. And that's what now we do with LCM, right? If you have two fractions, it normally do that, right? This by this is this. This by this is this. This by this is this. And then bring down the minus. Right? That's what you would have done if it were a normal something in it. Correct? Right. Now when you reach there now, we had to find a way. You all seen any plus here? No. I'll find out we can get rid of that, right? What is 1 minus cos squared? 1 minus cos squared is sine squared, right? So I'm going to get sine squared over cos theta. Sorry, sine squared over theta, cos theta. Are you okay with that? But is that the answer? Right. When you reach places like this and you find a stick, here's a little cheat code that I can use. Secretly go on the right hand side and work it out a little bit. Right? So it will be sine theta. Tan is what? And what is sine by sine? Same thing. Aaron? Same thing, right? So now I just have to go backwards. I just have to write it like this. And this is tan. And that's it, QED. Lovely. Right? So sometimes you need to play with our right hand side a little bit. Okay? Now go again. Huh? You don't need to show that now. They're not interested in that. They're interested in that you take one of the sides and make it look like the next side. Right? You don't have to show this. That's just a help for you. Alright, online, try this one on a little quiet online there, except for nobody else answered. All right, take this real easy one here. Online, once again, that's QED. It says 1 plus tan squared by cos squared is 1, right? Right. Yeah. Well, yeah. What you got? You get none? Come. You gotta get one. So, what's this one here? Let's start with this one. Alright? They have costs. They have any costs? Which rule here you could use cost squared? Cost squared is equal to, correct? Wait. So you tell me take off cost squared and write what? 1 minus sine squared, right? Minus sine squared. Sine minus sine squared minus sine squared. How much sine squared? Alright. What is that? Minus x is how much? You sure? Right? Same thing here, right? 1 minus this is 1 minus 2. And that's it. That's okay? That's all. All okay with that? How about this one here? Doing this. Okay. So you want to get 1, right? So you got to get rid of this and this. So what's the first thing you can do? Change tan, right? Tan is sine over cos. Right. So if it's squared, it will be sine squared over cos squared. That's all. And you multiply that by cos squared. Now we're going to multiply cos squared by 1. I'll get cos squared by sine squared and cos squared. This will cancel. And you'll get sine squared. Enough? This will cancel here. Cos squared plus sine squared is 1. That's it. That's the easiest I could give you. Now I to give you a real question here. This was in the office of the paper. Online, or you just I can hear you. Anybody else any online? Oh, it's sent on WhatsApp. All right, that's good. So all you have to do is just say here we go. All right, see how far you get to this one. Not so hard. Try that, please. Last one. Right, you also had exam starting on the what? Yeah. Second time, but that's the last one. Okay, ready? Are you ready? Which is your one photo? Right? So left hand side, 1 on cos squared, right? Right hand side, sorry, tan squared is. I want to get one here. So somehow or the other, things are to cancel off, or maybe I get something like this. Okay. So what can I do here? They both to the same denominator, so I could probably find the LCM, cos squared by 1, cos squared by this is 1, cos squared by this is sine squared. And then I might recognize that 1 minus sine squared, 1 minus sine cos squared. So technically I have cos squared over cos squared, which is right. Right, so that's one thing you could have, that's something that you could have done. Huh? Huh? Yeah, sorry. The little box means I put. Huh? After you make this equal to the right hand side, you write QED for your right little box. Right, so next week. Oh, I'm gonna type on next week, right? Huh? I know, but it's confirmed. I confirmed it now. I don't guess it. Yeah, even though we doing that, one of the days that we will go to like seven. I'll provide food. I'll provide food. Right, that's what we try to bring back 5 5.